Bismillah. So this video is for assignment 2 of intelligent control system, and it's me first, Abdurrahman Hajjo. My MATIC number is 191476, and I'm doing it with Muhammad Al Mursi. So the choice we got is about smart grid, and we are going to talk about introduction, the application chosen, and answer several questions based on that, and ending up with conclusion. So to start with the introduction, why smart grid? First of all, the world energy consumption is increasing tremendously in the recent decades, and that's causing pollution, greenhouse emissions, and thus climate change. So in order to reduce that, we are turning around to make use of the more renewable energies and green energy. And in order to do that, we have to rely on sources like solar and wind. And as we know that the complexity of the electrical power network is increasing also. And by integrating the smart grid or the renewable sources to that, we will get an issue of solving the frequency changes due to the change in demand and production. So in the traditional way, in the conventional network, the supply is fixed and the demand is changing. But in the smart grid, it's actually two ways change from the supply and from the demand. And that causes fluctuation in the frequency that we need to resolve. Next. So in the chosen example here, we have a diagram showing a model of a practical smart grid where solar power is used as well as wind, along with the diesel generation. And in this example is actually biodiesel generation is used in order to make it fully a green energy. So, and on the right lower side, we see that we have 3 storage units that where the energy from renewable resources will be stored. And as the supply as well as the demand fluctuates, the frequency will not be maintained. So in order to fix or to have a fixed rate of frequency, we have to control it. And in this example, a fractional order cascaded controller is used in order to maintain the frequency. Next. Now, what is smart about this chosen application is that the using of ASO, Atom Search Optimization algorithm, in order to tune up the parameters of the cascaded controllers. So instead of going to the traditional mathematical way, we apply a controller and we use ASO in order to tune those parameters. So how does ASO work? It actually relies on repulsive and attractive forces. So the repulsive forces of an atom avoids the crowdedness and trapping in a local minima by increasing the exploration ability of the search region. And as the distance between the atoms increase, the repulsive force decreases, which intensifies the attractive forces of an atom by exploiting the solution gradually to global minima. So ASO algorithm possesses the characteristics of exploration and exploitation behavior to search for the optimal solution. And the output graph of that system showing we obtain a very good results with the minimum overshoot, short transient response in general. So we get to zero steady state error in a very reasonable time. Next. So here comes a very important question. Is the technology sustainable? And Mursi, my friend Mursi will continue on that.
Okay, so hello, assalamu alaikum. So the question to answer, we have the first question: is the technology is sustainable? So there are worries and questions on whether a smart grid with RES would affect the economy and the society of a country positively or negatively. Will a shift from the fossil fuel generated power to the renewable energy sector change the way the world is going to function economically and thus socially? This is because in terms of the environment, it will bring a positive outcome that is very much needed to bring a stop to the climate change the world is facing today. So the next question is, what is the impact of the technology on the environment? So we will talk in general of the advantages and disadvantages. For the advantages of the smart grid, so it reduces the electricity theft and it reduces electricity losses. It reduces electric cost, meter reading cost, T&M operations, and maintenance costs, etc. It reduces equipment failure due to automatic operation based on varying load conditions. And the most important one, it reduces air emissions of CO2, COX, all the emission of SO, and all the emission of NO and PM 2.5. Hence, smart grid contributes to keep the environment green. The following disadvantage is the continuous communication network should be available, which it will make the whole network be exhausted. During an emergency, network congestion or performance are big challenge in a smart grid system. Cellular network providers do not provide guaranteed service in abnormal situations such as windstorms, heavy rain, and lighting conditions. Some smart meters can be hacked, which can be used to increase or decrease the demand for power. It's expensive to install smart meter compares to traditional old electricity meters. So in general, the disadvantage, it's not, there are no big deal with disadvantages on the environment, but it actually have a disadvantages on the network in general and for the economy in general. So is the current technology in the market employing intelligent control or model? So the smart grid is enabling the collection of massive amounts of high dimensional and multi-type data about the electrical power grid operations. By integrating advanced metering infrastructure, control technologies, and communication technologies, artificial intelligence is applied successfully to solve many industrial problems such as neural network, physiologic controls, evolutionary computation, and hyper intelligent system. Because of the rapid revolution of the modern power system, more distributed smart grid components, including smart metering infrastructure, communication infrastructure, distributed energy resources, and electrical vehicles, are tightly integrated into the power system by encompassing a huge electrical power network with underlying communication system. What is the suitable business mean? What is the suitable business model? The suitable business model that we found is the first, smart grid business models are characterized by remarkable scalability properties that make them geographically adaptable to various countries. The business model is a prerequisite for the value proposition, social and economic value to be appraised with a cost benefit analysis. The most challenging estimate is probably represented as it happened in most industries by the revenue stream. The digital smart meter market may be segmented by technology, application, delivery mode, components, and end user. Uh, so how we are going to form up a start company? I will leave this question to my friend Abdurrahman.
All right. So startup startups are normally debt-free since they have little, if any, collateral value of their assets, and they produce negative cash flow, especially in the first years of the existence. Consequently, in the balance sheet, raised capital or funds tend to coincide with equity. In the income statement, EBIT is like the net result, uh, considering that interest rates are non-existent and taxes also. So in the cash flow statement, the operating cash flow tends to coincide with the net cash flow. In the absence of the cost of debt, the cost of capital coincides with the cost of equity. So liquidity derives from initially negative and so cash absorbing, but with high increase potential. A change in operating network capital, sales growth fueled by cash absorbing expansion of the receivable and stock, partially counterbalanced by a cash generating increase in payables. Change in the CAPEX, net of cash flow description or amortization, and equity and quest equity injections, considering only liquidity cashed in and not a cashless contribution in kind. So next is what can be proposed to the existing company to add up value to the product. An example here comes with the smart grid integrated with the use of electric vehicles. So one of the biggest environmental issues is pollution due to vehicles. The use of electrical vehicles has the solution to that problem. Smart grids have advanced technologies in form of communication, smart meters, and control. So it has a potential to offer electric vehicles not only as a load, but it also can be used as a flexible energy source. Smart meters play a vital role to address the challenges faced by the grid due to the electric vehicle, as these meters have bidirectional. So as these meters have bidirectional communication ability and to monitor real-time data, these smart meters can help in implementing a smart scheduling to optimize the available power in the grid. So next, how much does that technology cost? And is it worth investment? And how much percentage performance improvement is expected? So the investment, the deployment of smart grid technology from the US utility control centers and the power network to consumers' homes, or to consumer homes over the next 20 years could cost between $338 billion to $467 billion, but will deliver benefits over that period between 1.3 trillion to $2 trillion. So the investment in the high cost scenario would go into upgrading the high voltage transmission grid, including installation of sensors and purchases of equipment to protect the grid and to make it more efficient. That will take about 20%. Next is the question, how would I break down the financial cost? So included the estimate of the investment needed to realize a smart grid. There are estimated expenditures needed to meet load growth and to enable large-scale renewable power production. So as part of these expenditures, the companies of the expanded power system will need to be compatible with the smart grid. Generally speaking, and that's a study done in the city of, or the state of California, and the cost to enable a fully functioning smart grid, first for the transmission and substations, it will cost around 82 to 90 million dollars. While for distribution, it will cost around 230 to 339 million dollars. And the cost by the end consumer, that's including the final the home lines and the meters, it will cost around 23 to 46 millions. So the total cost will be around 337 to 467 millions. So next is the question of the steps and the stages of implementing such a project.
So I will begin right now to show the budget and the project timeline. This is the timeline that we developed to meet the project and the budget timeline. So the first thing is the project development, which is including internal and external approvals of budget and scope. Next is the regularity approvals if required, pre-planning and preparation, equipment purchases, such as equipment purchases and installation, development of marketing, communication, and customer requirement materials if relevant. Time required to measure baseline conditions, field implementation, data collection and monitoring, time required for data collection, processing, analysis, and report writing. So this is the timeline for the activities that it should be done if we estimated the time of the project is from 2013 to 2016. So this is just an example. And the stages of implementing such a project is the estimated steps are considered in the case of having an adapt and implement smart grid technology and interconnect it with the conventional grid to finally be delivered to the end consumers. Following this is the flow chart with the present stage to apply the smart grid technology. So we'll go with generation, cogenerations, renewable plus fossil fuels, renewable solar wind farms. These are the generations. And then we'll go to advanced transmission, which is high voltage DC, grid monitoring, energy storage, advanced metering infrastructure. Then we'll go the distributed generation renewables to the home area network. So this is all from us. Thank you so much.
Thank you.